This is Chapter 5, Section 7, titled Scatter Plots and Trend Lines, day number 2. So let's take a look at our first problem here, and it's asking us to come up with a scatter plot for the information below. Students measured some diameters and circumferences of tops of a variety of cylinders, and below are the data they collected. So let's go ahead and take a look at the x value. What depends on the others? So circumference is going to depend on the diameter, is what is going to end up happening, and we're going to see that when we come up with the formula, and we're going to find out what that rate of change is, and hopefully it's a fairly constant rate of change. So when we're looking at the first value, I'm going from 3 all the way up to 12. So I'm going to start with writing in, I've got my diameter down below. Change my pen so it's a little bit smaller here. And so I've got my diameter down below, and that is in centimeters, and I'm going to have my circumference alongside the x-axis, and that is in centimeters as well. And so we've got centimeters here, and what we'll do is we'll take a look at the numbers that we've got to go from. So 3 to 12, and so I'm going to end up using values of 1.5 to be able to get all the way up there. So I'm going to start here at 3, and then this would be 4.5, so this would be 6, 9, 12, and 15. This will ensure that I get all the way to 12. And then when I look at my circumferences, I've got to go from 9.3 to 39. So I've only got 10 spaces here. So if I take a look at, if I was going from 39.5 is about 40, divide that by 10, I've got to go up by 4s. And so that's what I'm going to do. Each space is 4 spaces, or 4 centimeters. So there's 8. This would be 16 here. And then 24, 32, and then I'd be able to get up to 40. And that will ensure I have enough space for everything. And now I've got to plot these values. And so as I look at this, my first one is 3, 9.3. So that's going to end up being somewhere right around in here. And then I've got another 3, and it's a little bit higher. And then I go to 5, 16. So that's going to be somewhere in this region here. And then I go to 6, 18.5. So I'm along the 6 line, and 18.5 is going to be somewhere in this region here. So this would be 17.5, so it's going to be a little bit higher than that. So let me go ahead. Actually, no, these are going by 4s. So 18.5, that's about right. So this would end up being 20. So it's going to be a little lower, but that's pretty close. So 825. So 825 is going to be somewhere in this range here. But then I have another 8, and I had 25.6. So it's really hard to be able to fit that on this small graph here. And then my 9.5, or 9.5, 29.5. would end up putting me somewhere in this region here. And then I have a 1031 and 31.5, and a 1039, or 30.9. So that's going to be somewhere in this region here. I'll just put one above the other. And then my last one is 1239.5. So somewhere up in this region here. Alright, so now I've got it. Definitely looks like I've got some positive correlation going on. Positive correlation. I see that it looks like it's going to end up forming a line, and so I'm going to use a trend line. My trend line is just an approximate. You see, it's hard to be able to do it, and again, you'd want to use a ruler as you do it, so yours should be straight. Mine's not going to be as straight because I got a free-handed here. So as I go ahead and do it, I'm thinking it's going to come somewhere in here, and I'm going to tail off to that point there. And so I know it's going to end up going through the origin because it makes sense. Because if I have no diameter, I should have no circumference. And so that's what one thing I do realize. And so that's where I'll start. Now, when I look at this, I've got a point. It looks like it's going to end up crossing right about here. So I'm going to use that point, and I'm going to go down here and use the origin also as a point. And so this point is 10.532. So 10.5, 32, and then I'm going to use the origin of 0, 0. So what I want to do now is find out what my slope of the line is. So my slope is going to end up being the change of y, so 32 minus 0, over the change of x, 10.5 minus 0. So that's going to be easy, 32 over 10.5. So I go ahead and use the calculator there, and I'll do that division, 32 divided by 10.5, and that gives me that number. So I'm going to round that just to 3.05. So m equals 3.05. So now I'm going to use the point slope formula. So I'll use the point 10.5 comma 32. So y minus 32 equals 3.05 times by x minus, and then my x value was 10.5. So I go ahead and distribute. So 3.05x, and then over here I'm going to have minus. Now let's go ahead and multiply that out. So times, again I changed that just to 3.05, times by 10.5, and that gives me 32.025. So 32.025. So I go ahead and add the 32. And remember what I said about the diameter being 0, the circumference would be 0, and that's just about what we have. We don't have exactly that, but that's okay. Remember, this is just a trend line. It's not exact, and so it's what we've got with what the data we have. And so the 32s will cancel out, so I'm just left at that 0.025, which is kind of negligible. So we could even leave it off, but I'll leave it on for now, just because those were my points. And so that's what I have for the line. This is just the equation of the line, and now I'm going to predict some what the circumference would end up being with a diameter of 20. So I'm going to put 20 in place of x, because that's what I used for my x values was diameter. My y values, outputs, were circumference. So 3.05, and I end up multiplying by a value of 20, because that's what I said it would, and I'll just go ahead and leave that 0.025 on there. And when I go ahead and multiply these, let's see what we get. So we have 20 times by, and then 3.05, and that gives me 61. So 61, and then I have to subtract that 0.025, and so that's going to end up giving me, actually, subtract that value, and it's going to give me a decimal somewhere a little bit smaller than that. So minus the 0.025 makes 60 and 9.975. So there it is. That would be the circumference of a circle. So circumference with a diameter. The diameter of that diameter was 20 centimeters. So now what we're going to do is we're going to take a look at another way we could end up coming up with this trend line, because our trend lines are always going to vary. So you might have a different number here. And really what this is, remember our circumference formula, just to go back a little bit, is diameter times pi. And so the diameter, we said, was 20. Well, we multiplied by 3.05. Well, that 3.05 is just a little bit off. See, that really should be a little bit better representation would be the 3.14. So whenever you are doing this, for this problem, you should get some number. Your slope of the line should be pretty close to 3.14. Mine was fairly close for the information I have. But we could see what the answer would be with a best fit line. So that's what we're going to take a look at real quick. A best fit line uses regression to come up with a solution. Now there's it's a fairly complicated formula using the different points and how far they are, and so what we can do is use a calculator to help us come up with that, and so that's what we're going to end up doing on this problem here. And so let's take a look at how to do that. And so I'm using this Casio, and this is a 300 ES Plus, and so the way we're going to end up doing that is we're going to start with coming up with the stat mode. And so I end up having to press the mode button here, and I'll have these three different choices. So I'm going to press number 2 for stat, and when I do that, you see how we have these different choices. This is the one we want, this ABX, and so let's talk about what that means real quick. And so when I have that ABX, A plus BX, B is in statistics form, they end up using this as their slope. So this represents their slope, and the A represents the y-intercept. And then they end up using this y with a hat on top, and this is just an estimate for y. And so we're going to go ahead, and now we're going to press number 2 there. and that leaves us with a table. And so what we'll do is enter our data. So our data on the x values go 3, and then we press equals to be able to move down, and then we continue on. So 3 equals, 5 equals, 6 equals, 8 equals, 8 equals, 9.5 equals, 10 equals, 10 equals, and 12 equals. So now we've got all that data, at least for the x's. Now we're going to go to the y's. So I'm going to end up pushing the arrow key down, which will bring us right back up to the top, and then the arrow key to the right, and that brings me to the y-axis, or the y values. And so I start entering those. 9.3 equals, 9.5 equals, and then I got 16 equals, 18.8 equals, 25 equals, 25.6 equals, 29.5 equals, 31.5 equals, 30.9 equals, and a 39.5, and then press equals. Now I've entered all the data. So my next step is to press the AC button. So I press AC, and it zeroes it out, so it allows me to figure out some statistics forms, and I use the shift, and then I press number 1 for stat, and now I've got some different things I can do. So I can find like a sum of data, variance, minimum, maximum, but I'm going to pick the one that says REG. That stands for regression lines. So I'm going to press 5, and now I've got all these different choices, A, B, R, and X. Let's take a look at them real quick. So remember, the A stood for the y-intercept, where B stood for the slope, and the y-hat, well, that's an estimate for y given an x value. We're going to use those. We're also going to take a look at this R. This R stands for the coefficient correlation, or maybe correlation coefficient, and that'd probably be a better way to say it. So correlation coefficient, and it runs between two values. It's going to end up either running between -1 to 1, and then 0 will put in there. 0 has no correlation. -1 has negative correlation. That means that it's going to end up being a line that goes downhill from left to right. 1 is positive correlation. So what you want, if your data is good, you're going to get a number, if it's positive, a slope, you're going to get a number close to 1. If it's a negative slope, you get a number close to -1. So you always want a lot of 9s in the problem. You want a correlation coefficient that is about somewhere around like 0.9999 and then some other numbers. And that would represent a positive one. A negative 0.9999 would end up representing a negative slope. So we're going to end up taking a look at all those different values. And so in this calculator, I'm going to end up pressing 1 first, and then equals, and it gives me this number, 0.375. So that represents the y-intercept for our values. So it's negative also. So I'm going to write down A equals negative, and that was 0.37, and I'll just write 6 because I've rounded it up. And then let's take a look at the next one. So we'll go back to that, and we're going to press AC, or let's press AC for clearing, and then we'll go back to the shift 1 and then 5, and then I'll press number 2. So I have to do that each time to be able to get to this value here, and it gives me a B value of 3.21. So we'll write that down. So B equals 3.21. And then I'm going to go with the R value. Let's do the R value next, and to see how good of a line we end up having here. And so we'll go back to that calculator, and we'll press AC, shift 1, 5, and 3 for R, and let's see how good it is. Okay, 0.998. So that means that it's pretty good. 0.998 means that we've got a decent line here, 0.998. So it's fairly close to 1. And so from there, we're going to go ahead and do a y-hat. And so far what we've got is our equation would be this. It would be 3.21x and then minus 0.376. And so let's go ahead and check out, and I'll go ahead and put the y-hat. We're going to end up using a value of 20 and see how close we are. See, last time we ended up getting 60.975 for our trend line. Let's see what the calculator gets for best fit line. Now this is the best fit line. This is the one that represents the data the best. So again, all our answers should be fairly close to that. Let's take a look at our number though when we go ahead and do it. So we'll clear AC, shift 1 again, and then 5 for our regression line, and let's press 5 for the y-hat, and then I've got a cursor to the left, to get the cursor to the left now, and then let's enter what we want. We wanted a 20 centimeter diameter. Let's press equals and find out what it is. And so here's the number they had. 63.88 is what they got. 63.88. So that's what they got with their value. Again, fairly close to what we have. And so that's a best fit line. Best fit is the best equation that you can come up with. Trend line, just whatever you end up coming up with depending on how you end up drawing your line. So we can use this calculator to help us find these and then predict values either into the future or either extrapolate or interpolate either in between values or outside the region that we have. So those are types of problems you'll see on the homework tonight. Good luck.